There is a continent no one told you about. Not in the geography lessons where you memorized the seven and drew their outlines on blank paper with the particular concentration of a child who has been told that this matters. Not in the atlases with their color-coded elevations and their confident borders. Not in the documentaries that play in the quiet hours when the rest of the world is sleeping and you are still awake, searching the dark for something you cannot name. Not once, in all the years of being taught the shape of the world, did anyone mention that the shape of the world is incomplete, that the map you were given has a missing piece, that beneath the surface of the ocean, beneath kilometers of cold, dark water, beneath the weight of a sea that has been sitting on top of it for 85 million years, there is a continent, a full continent, with mountains and valleys and the kind of geological history that takes hundreds of millions of years to write. Sitting at the bottom of the Pacific Ocean, waiting. It has always been there. It was there before the maps, before the ships, before the first human being stood on a shore and looked out at the water and wondered what was on the other side. It was there before human beings existed at all, before the animals that would eventually become human beings existed, before the first fish pulled itself onto land and took its first uncertain breath of air. It was there before the dinosaurs. Before the first flower opened on any hillside anywhere on this planet. The continent was already old when the first grass grew, already ancient when the first bird learned to fly. It has been sitting beneath the ocean longer than most things that exist have been alive to sit anywhere at all. And no one knew. That is the part that should stop you. Not the size of it, though the size of it is extraordinary. Not the depth of it, though the depth is extraordinary too. The part that should stop you is the knowledge. Or rather the absence of it, the gap. The continent-shaped hole in the map of everything we thought we understood about the world we live on. For all of recorded history, for all of the centuries of navigation and exploration, and the drawing and redrawing of coastlines, for all of the scientific revolution and the geological surveys and the sonar mapping and the satellite imaging, for all of that accumulated effort of human understanding pressing itself against the unknown and slowly, painstakingly, turning the unknown into the known, this continent sat beneath the water and was not known, was not named, was not included in the count. We thought there were 7. There are 8. The continent is called Zealandia, and the ocean above it is not hiding it. The ocean above it is simply the ocean. It has no reason to announce what is beneath it. The ocean does not perform its depths for the benefit of the creatures that live on the surface. It simply is what it is, deep and cold and continuous, covering 94% of a landmass the size of Greater India with the same indifferent thoroughness with which it covers everything else it covers. The ocean does not know it is keeping a secret. There is no secret being kept. There is only a shape in the rock, a continent-shaped arrangement of continental crust sitting mostly below sea level, patient as only geological things can be patient, waiting not for discovery, not for the moment of being found, but simply continuing to be what it has always been. A continent, the 8th one, ours and unknown to us for the entire duration of our knowing anything. You are about to descend into it. Not with your body. Your body is already still, already resting, already beginning its nightly surrender to the small gravity of sleep. But something in you, something that has always known the way that deep things know, that the surface of the world is not the whole of the world, that the edge of the map is not the edge of what exists. That part of you is already leaning toward the water, already curious about the dark below it. Already beginning to understand that the world is larger than you were told, and that the largeness is not frightening. It is a gift. It has always been a gift, the largeness. Every time the map has had to be redrawn. Every time the known world turned out to be smaller than the actual world. Every time a ship returned from beyond the horizon with news of a coastline that the cartographers had not yet drawn, something in human beings has responded not with dread, but with the particular feeling that has no simple name. The feeling of a world that keeps being larger than expected. The feeling of an existence that keeps offering more than it has already given. The feeling that there is always, if you are willing to go far enough and deep enough and patient enough, something else, something more, something waiting beneath the surface of what you thought you knew. Zealandia is that feeling made geological. Close your eyes. Let the water rise around you, not cold, not threatening. Simply present the way deep things are present. Patient. Dark in the way that depth is dark, which is not the darkness of absence but the darkness of distance, of fathoms, of the particular quiet that exists in places where light has given up its journey and turned back toward the surface. You are going in the other direction. You are going down toward the mountain ranges and the ancient riverbeds and the drowned valleys of a continent that the ocean has been keeping for 85 million years. You are going to find out what the world has been holding beneath the water while the world above the water was busy becoming what it is. Take one slow breath. Feel the weight of it, the good weight, the weight of a body that has been carrying itself through the world since morning and is now in this darkness, in this stillness, ready to put something down. The continent below the water has been putting things down for a very long time. Mountains that were once as high as the Himalayas, worn down by rain and wind and the slow erosion of geological time, then covered by the sea, then pressed lower and lower under the weight of all that water. Everything that Zealandia once was, it has set down. And what remains is not diminished by the setting down. What remains is the shape of it, the bones of it, the deep and patient truth of it, preserved in the rock beneath the water, waiting to be read by anyone willing to go deep enough to read it. We are going that deep tonight. Before we descend, stay for a moment with the word continent. We use it the way we use all familiar words, as though the familiarity settles the matter. 7 continents. Everyone knows what a continent is. And yet, if you ask a geologist, a real geologist, someone who has spent their working life with their hands in rock and their mind in deep time, what a continent actually is, the answer is more interesting and more uncertain than the word suggests. A continent is not defined by the water that surrounds it. That is coastline, which is a thing that changes. Coastlines have been in different places at different times throughout geological history. The coastlines of today are the coastlines of this particular moment in the 4.5 billion year story of a planet that has never stopped moving, never stopped rearranging itself, never settled into a final form and decided to stay. A continent is something deeper than its coastline. A continent is a piece of continental crust, a thick, relatively light slab of rock, different in composition and in density from the oceanic crust that makes up the floors of the ocean basins. Continental crust is granite and its relatives, lighter rocks, rocks that float higher on the mantle beneath them, rocks that tend to remain above sea level because of what they are made of and how much of them there is. But tend is not always. Tend is a statistical truth, not an absolute one. And Zealandia is what happens at the edge of the tendency. It is continental crust that did not stay above sea level. Continental crust that stretched and thinned over tens of millions of years until it became thin enough, light enough, different enough from what it had been to sink beneath the surface of the sea. Not to disappear, not to cease being continental crust, simply to descend. to take its continent nature below the waterline and continue being what it was in the dark, under the weight of the ocean, for longer than any land animal has existed anywhere on Earth. Think about what it means to be a thing, and to continue being that thing even when no one can see you. Zealandia has been doing that for 85 million years. It has been a continent in the dark, a continent under the water, a continent without any land creature walking its surface or any plant growing in its soil, without any rain falling on its mountains that did not first pass through kilometers of ocean to get there. It has been a continent without any of the things we usually associate with continents, without forests or rivers or deserts or the particular quality of air on a high ridge where you can see the horizon in every direction, without any of that, and still a continent, still, in the precise geological sense, what it has always been. The definition does not require witnesses. The definition does not require the continent to be visible or accessible or known. The definition requires only the composition of the rock and the thickness of the crust, and the particular relationship between density and buoyancy that makes one kind of rock a continent and another kind a seafloor. Zealandia has all of those things. It has been all of those things since before the first human ancestor stood upright on the savanna of a different continent and looked at the sky and began, slowly, over hundreds of thousands of years, to wonder. It has been a continent for longer than we have been wondering. And now, finally, improbably, after 85 million years of being what it is in the dark, we know. The discovery was not dramatic in the way that discoveries are supposed to be dramatic. There was no single expedition, no singular moment of revelation, no explorer standing on a deck in the rain watching a coastline materialize from the fog. The discovery of Zealandia was a discovery made in conference rooms and at computer screens, in the patient analysis of data that had been accumulating for decades, in the slow work of scientists who kept looking at the numbers, and finding that the numbers were saying something that the maps had not yet said. It was made by a team of geologists, published in 2017 in a paper with the deliberately understated title, "We should recognize Zealandia as a drowned continent." Not "we have found a lost world," not the eighth continent revealed. Simply, we should recognize, we should update the record, we should make the map accurate. The continent has been there the whole time. We are only now catching up to it. Nick Mortimer was one of the scientists who wrote that paper. He works for GNS Science in New Zealand, and he has spent years thinking about the rock beneath the water. When he talks about Zealandia, he talks about it the way geologists talk about all geological things, with a precision and a patience and a sense of time that makes everything else feel slightly hurried. The rock is there, the data are clear, the conclusion follows. The continent is real. It has always been real. The only thing that has changed is our understanding of it. That is what knowledge does. It does not create the things it discovers. It finds them. It recognizes them. It adds them to the list of what is known, which is a list that has never been complete and will never be complete because the world keeps being larger than the list. But each addition is a kind of gift, a moment when the universe offers something it has been holding quietly, waiting for the question to be asked in the right way, with the right instruments, with enough patience and enough curiosity to go looking in the right place. The right place, in this case, was the bottom of the Pacific Ocean. The right instruments were sonar and satellite gravity measurements, and the analysis of rock cores drilled from the seafloor, each one a small cylinder of geological time, layers of sediment and basalt, and the compressed remains of ancient organisms that lived and died in water so deep that their shells, falling through the darkness after their deaths, took months to reach the bottom. each core a record, each layer a page in a book that the ocean floor has been writing since before there was anyone to read it. We are reading it now, and what it says is this: beneath the water, there is a continent. It has mountains. The tallest of them break the surface of the ocean in two places, in the islands of New Zealand to the south and New Caledonia to the north. The only parts of Zealandia that the ocean has not covered. The only places where you can stand on the rock and know you are standing on the 8th continent without needing to dive to find it. Two small archipelagos, standing above the water like the tips of something much larger, like the visible portion of an iceberg that extends far deeper than the surface suggests. Only in this case, the iceberg is a continent, and the part you cannot see is 94% of its total area, sitting quietly at the bottom of the Pacific, patient as geology, waiting for nothing, needing nothing, simply being what it is. What it is ancient. What it is vast. What it is the largest thing that the modern world did not know until the modern world was already old enough to be embarrassed by not knowing it. And what it is, tonight, for you, in the dark and the stillness and the slow descent into something larger than the surface has room to show you, is the beginning of a journey into the shape of the world beneath the world. Breathe. The water is not cold. The dark is not empty. The thing you are descending toward has been here longer than almost anything that exists has been anywhere. It has been here waiting, not for you specifically, not with any awareness of waiting at all, but with the geological equivalent of an open door. Simply present, simply real, simply the 8th continent, sitting at the bottom of the Pacific Ocean, ready at last to be known. We are going down to find it. Before the drowning, there was a time when Zealandia was not beneath the water. This requires a particular kind of imagination. Not the imagination that invents things that have never existed, but the harder, quieter kind that takes something real and runs it backward through time. That looks at what is and asks what was. That holds the present still for a moment and peers behind it at the deep past, at the version of the world that existed before the version we know, and the version before that, and the version before that, going back and back through the layers of geological time the way you might page backward through a very old book, each chapter stranger and more distant than the one before, each one written in a language that requires different instruments to read. Zealandia was once dry land, not just slightly above sea level, not just a low-lying coastal plain occasionally flooded by high tides and storm surges. Zealandia was mountains, real mountains, tall and cold and white at the peaks, the kind of mountains that make weather, that force the clouds coming off the ocean to rise and cool and drop their rain on the western slopes while the eastern slopes stay dry in the shadow. The kind of mountains that have glaciers in the high valleys and rivers running down every flank, carving the kind of deep and permanent valleys that become the most beautiful places in any landscape that contains them. Zealandia had all of that. It had a surface. It had soil. It had rivers that ran from those mountains to a coastline and emptied into a sea. It had weather. It had seasons. It had the kind of landscape that, had any creature been alive and capable of standing on a high ridge and looking out across it, would have taken the breath away with its ordinary magnificence. No such creature existed. Not yet. This was a world before us, before anything like us, before the lineage that would eventually produce us had yet branched away from the lineage that would produce everything else. But the mountains were there. The rivers were there. The landscape was there, doing what landscapes do in the absence of observers, simply being what it was, indifferent to its own beauty, indifferent to everything, following the laws of physics and geology and erosion and precipitation with the absolute consistency of things that have no other option. This was roughly 500 million years ago. The number is difficult to hold. 500 million years is not a human scale of time. It is not even a civilization scale of time, or a species scale of time, or even a mammal scale of time. 500 million years ago, the most complex animals on Earth were things that left no descendants we would recognize, soft-bodied creatures in shallow seas, experimenting with body plans that evolution would later abandon, feeling their way toward complexity without any destination in mind. The land above the sea was bare rock and early soil. No forests, no grasslands, no flowers. The sky was different, the oxygen content lower. The sound of the wind over stone the only sound there was because there were no trees to move in it and no birds to ride it and no insects to fill it with their particular frequencies. Into that world, Zealandia was born. Not from nothing, not as a new thing arriving into existence from outside existence, but as a piece of something larger, a piece of the supercontinent, a piece of Gondwana. Gondwana is a word that belongs to the category of words that carry more meaning than their syllables suggest. It is a name given by geologists to a landmass that existed before the continents we know existed, before the Atlantic Ocean had opened, before Africa and South America had drifted apart, before India had broken free and begun its long northward journey toward the collision with Asia that would eventually raise the Himalayas. Before all of that, there was a single vast southern landmass. A supercontinent that contained within it the geological ancestors of Antarctica, Australia, South America, Africa, the Indian subcontinent, Arabia, and at its eastern edge, the piece of crust that would eventually drift away and become, partly, what we now call New Zealand, and partly, much more of what we now call the floor of the southwestern Pacific Ocean. That eastern edge is where Zealandia begins. Not as a continent in its own right, not yet, but as a region of continental crust attached to the larger whole, part of the vast coherent mass of Gondwana, indistinguishable from the rest of it except in the specific composition of its rock, in the particular way its crustal basement was assembled during the ancient collisions and accretions that built Gondwana in the first place. The rock that would become Zealandia was already old when Gondwana was at its greatest extent. Old in the geological sense, which is a different kind of old from any other kind. Old in the sense of having already been mountains and eroded flat and buried and metamorphosed under heat and pressure, and uplifted again and eroded again, multiple times over hundreds of millions of years, before the story we are telling even begins. The story begins with the breaking. Gondwana did not last. No supercontinent has ever lasted. Not because there is something wrong with supercontinents, not because the forces that hold them together are weak or unreliable, but because the same forces that hold them together also, over sufficient time, pull them apart. The mantle beneath the crust is not still. It moves slowly in vast convection cells driven by the heat of the Earth's interior, heat left over from the formation of the planet and heat generated continuously by the decay of radioactive elements in the rock. The mantle moves and the crust moves with it, and where the mantle diverges, pulling in two directions at once, the crust above it stretches. And when crust stretches far enough and thin enough, it breaks. A rift forms. The rift widens. Water finds its way in. And what was once a single piece of land becomes two pieces, then four, then more, drifting apart on the slow conveyor of the mantle beneath them, each piece becoming, in geological time, something new. This is how continents are made. And this is how Zealandia was made, by the breaking of Gondwana, by the rifting and the stretching and the slow separation that began roughly 180 million years ago and continued, in stages, over tens of millions of years, until what had been the eastern margin of the supercontinent was a separate piece of crust adrift in the Proto-Pacific Ocean. The separation was not clean. It never is. The edges of rifting continents are complicated places, stretched and thinned and faulted. The crust pulled apart like taffy until it is thin in some places and thick in others, until what was once a high mountain range has become a low coastal plain, and what was once an inland basin has become a shallow sea. The eastern edge of Gondwana, as it rifted away to become Zealandia, went through all of this. The mountains that existed along that margin were tall at first, fed by the tectonic activity of the rifting, built up by the collision and subduction happening along the ancient plate boundaries. Geologists call this period the source of the Zealandia Mountains, the time when the region that would eventually sink was still, in some places, rising. 85 million years ago, the separation was complete. Zealandia had fully detached from what would become Antarctica and Australia. It was an island continent, its own piece of crust, floating on the mantle the way all continental crust floats, buoyant because of its composition, sitting higher than the oceanic crust around it. It was smaller than it had been. The rifting process stretches and thins the crust at the margins, and much of what had been the high elevation interior of the old Gondwana margin had been worn down by erosion and lowered by the thinning. But it was still above the water. Still a continent in the full visual sense, in the sense that would have been immediately recognizable to any observer capable of seeing it. Land, a landmass. The eighth continent before anyone knew there would eventually be a count. And then the sinking began. It did not happen quickly. Nothing in geology happens quickly. The sinking of Zealandia is a process that took tens of millions of years, a process so slow that it would have been imperceptible to any observer living through it, so gradual that no single generation of any creature that lived on Zealandia during its long drowning could have noticed that the land they lived on was lower than the land their ancestors had lived on. The change was measured not in years or centuries, but in millions of years, in the time it takes for a continent-scale piece of crust to thin and cool and slowly, inexorably settle lower into the mantle beneath it. The mechanism was the rifting itself. When continental crust stretches, it thins. When it thins, it becomes less buoyant. When it becomes less buoyant, it sits lower. The crust of Zealandia, stretched and pulled during the long process of its separation from Gondwana, had been thinned to the point where it could no longer maintain the elevation it had once had. And as it thinned and cooled, it settled. Slowly, over millions of years, the land's surface dropped. The coastlines crept inward as the sea advanced over the lowering edges. The rivers shortened as their mouths were drowned. The mountains, once as high as the Himalayas in places, were worn down by erosion and then covered, one valley at a time, one ridge at a time, by the advancing water. There were organisms living on Zealandia during this drowning. The continent had separated from Gondwana, carrying with it a sample of the life that existed on the supercontinent at the time of separation. The way a piece of wood drifting away from a shore carries with it whatever was living on the wood at the moment it drifted free. There were dinosaurs on Zealandia in the time before the Great Extinction. There were ancient amphibians and reptiles, and the ancestors of some of the most remarkable species that survive in New Zealand today. Creatures that have been evolving in isolation on that drifting and sinking piece of crust for so long that they have become unlike anything else alive on Earth. The tuatara, that ancient reptile that looks like a lizard but is not a lizard, that has been present in the New Zealand fossil record for over 200 million years, that has a third eye on the top of its head, and a metabolic rate so slow it can live for a century on the cold, rocky islands it still inhabits. The tuatara is a passenger from Gondwana, a survivor of the drowning, one of the creatures that made it to the high ground before the water covered everything else. Most things did not make it. As the land sank, as the coastlines advanced, as the forests and the plains and the valleys were covered one by the advancing sea, the life that had been living on Zealandia was reduced to whatever could survive on the shrinking high ground. And eventually, when the high ground shrank far enough, to whatever could cross the water to somewhere else or evolve fast enough to live in the sea itself. The Great Drowning was not a catastrophe in the way that asteroid impacts are catastrophes, sudden and total and simultaneous. It was a slow forgetting, a gradual loss of habitat so incremental that each individual loss was survivable, and only the accumulated losses, measured over millions of years, added up to transformation. By approximately 25 million years ago, Zealandia was almost entirely beneath the ocean. The only portions still above sea level were small, low-lying, subject to flooding, reduced from what had once been a continent-scale landscape to something closer to a scattering of islands, the precursors of what would eventually become the modern islands of New Zealand and New Caledonia. The mountains were gone. The rivers were gone. The plains and the valleys and the coastlines of the ancient landscape were gone, buried under kilometers of ocean, buried further under the sediment that accumulated on the seafloor above them over millions of years, layer by layer, the compressed remains of the organisms that lived in the water column above, drifting down after their deaths with the patience of things that have no reason to hurry. Zealandia was not dead. It was not absent. It was not nothing. It was exactly what it had always been, a piece of continental crust, following the laws that govern continental crust, sitting on the mantle, experiencing the slow, deep movements of the geological processes that have never stopped operating regardless of whether there is water above them or air. Volcanoes continued to form along the plate boundaries at its edges. Earthquakes continued to reshape its internal structure. The slow movements of the mantle continued to push and pull at it, and in some places along its edges, the compression of those movements would eventually push rock back above sea level, would rebuild islands from the drowned landscape, would give New Zealand its mountains and its earthquakes and the particular volcanic intensity of a piece of crust that has been tectonically active since before it had a name. But the interior of Zealandia, the vast drowned heart of it, sat beneath the water, sat and was silent, sat and accumulated sediment, sat and was unknown, even to the creatures who lived on the small islands that remained above the surface, even to the people who arrived on those islands eventually, the Maori, who came in canoes across the Pacific and built a civilization on the peaks of a drowned continent, without knowing that what they were standing on was the visible portion of something much larger, something ancient and geological and present beneath the sea in every direction around them. They knew the land they stood on. They knew the mountains and the rivers and the forests of the islands. They knew the sea around the islands with the profound and detailed knowledge of people who navigate by the stars and the currents and the behavior of birds over open water, people who read the ocean the way others read a landscape. They knew the shallow waters around the coasts and the deep waters beyond, but they did not know what was beneath the deep water. No one knew. Not then. Not for a very long time after. The knowing would have to wait for different instruments, for sonar that could map the contours of the seafloor, for satellite measurements of the gravitational field that could reveal the shape of the rock beneath the water from the slight variations in gravity above it, for rock cores drilled from research vessels through kilometers of ocean and through the sediment accumulated on the seafloor and into the basement rock beneath, each core a small cylinder of geological time, each one a sample of the continent that had been waiting, in its geological patience, for someone to come and read it. Rest now in the patience of it, the patience of the rock, which does not require acknowledgement to continue being what it is. The patience of the deep time that surrounds the human moment the way the ocean surrounds the islands, vast and present and indifferent to the scale of any individual life, but not indifferent to life itself, which it has been producing and supporting and dissolving and reconstituting for as long as the water has been liquid, and the chemistry has been willing, and the temperature has been close enough to write. The continent drowned slowly, and in the drowning it did not cease to be. It only became a different kind of presence, a presence beneath the surface, a presence in the deep, a presence that the ocean holds the way the dark holds everything it covers, not destroying it, not erasing it, only placing it in a different relationship to the light. You are in that dark now. The weight of the water above you is not a weight you feel because you are not a body in the ocean. You are a mind descending through it, moving through the layers of the sea the way light moves, attenuating with depth but not extinguished, reaching eventually the level where the water meets the rock and the rock meets the history, and the history meets the 400 million year story of a piece of crust that has been more things than most pieces of crust ever get to be. The continent is below you. It has been waiting. And in the particular way that geological things wait, which is not waiting at all but simply being, it is ready to be known. Breathe. The drowning took millions of years. You have arrived at its end. The rest of the story is the story of what was left behind. And what was left behind, it turns out, is extraordinary. The long descent. There is a kind of falling that does not feel like falling. You know the other kind. The kind that announces itself immediately, that sends the stomach upward and the heart into the throat, and the hands reaching for something solid before the mind has had time to process what is happening. That kind of falling is the body's oldest alarm, the reflex that predates language and thought and the ability to name what is happening. It is fast. It is total. It demands attention. But there is another kind. A falling so slow that no single moment of it can be distinguished from stillness. A descent measured not in seconds but in millennia, not in the lurching recognition of sudden motion but in the quiet accumulation of distance over time so vast that the word falling loses its meaning and becomes something else, becomes settling, becomes subsidence, becomes the geological equivalent of a breath slowly, completely, surrendering itself back into the body that produced it. This is how Zealandia fell, not in a rush. Not in the way that a coastline is suddenly swallowed by a tsunami or a riverbank collapses into the water below. Zealandia's descent was the slowest possible version of descent, a sinking measured in millimeters per century, in the imperceptible lowering of a landscape over the course of millions of years, in the kind of change that leaves no witness capable of noticing it, because the change is always slower than any life that might observe it. You would have had to watch for 1,000,000 years to see the shoreline move. You would have had to stand on a peak for 10 million years to feel it lower beneath your feet. The descent was real, and it was continuous, and it was, in the end, total. But it was the slowest total thing that has ever happened. To understand it, you have to understand something about the weight of rock and the memory of heat. When the rifting pulled Zealandia away from Gondwana, it did something to the crust that the crust did not immediately recover from. Rifting stretches rock. It pulls the crust in two directions at once, thinning it the way you thin bread dough when you pull it from the center outward. The crust that had once been thick, built up by the ancient collisions and compressions of plate tectonics, was now thinner, stretched, attenuated. And thin crust floats lower than thick crust, for the same reason that a thin piece of wood floats lower than a thick one. The buoyancy of continental crust on the mantle beneath it depends on how much of it there is. Reduce the thickness and you reduce the height at which it floats. Not by much at first, but over time, combined with the second factor, the cooling, the effect becomes enormous. The second factor is heat. When rifting happens, hot mantle material moves upward beneath the thinning crust, and the crust itself is heated from below. Hot rock is slightly less dense than cool rock, and less dense rock floats higher. So in the immediate aftermath of rifting, there is sometimes a brief period of elevation, a last gasp of height before the long descent begins. The heat that supports it begins to dissipate the moment the rifting stops. It radiates away into the ocean above. It is conducted slowly into the surrounding rock. And as the crust cools, as the thermal support for its elevation is removed degree by degree over millions of years, the crust settles. The cooling is inexorable. The laws of thermodynamics do not make exceptions for geological features that would prefer to remain above sea level. Zealandia cooled and it settled. Over 80 million years it settled. The rate was not constant. There were periods of faster subsidence when the tectonic forces acting on it changed, when new plate boundaries formed at its edges, and the stress regime in the crust shifted. There were periods of relative stability when the sinking slowed almost to nothing, when the balance between the buoyancy of the crust and the weight of the water above it reached a temporary equilibrium before being disturbed again by the slow and unceasing rearrangement of the plates beneath. There were even periods of uplift, when the compression of converging plates pushed portions of the drowned landscape back toward the surface, when the mountains of New Zealand were built and rebuilt by the collision of the Pacific Plate and the Australian Plate along the fault system that still today makes New Zealand one of the most seismically active places on Earth. But the overall trend was down, has always been down, is still down in some portions of the continent even now. Think about what it means for a landscape to slowly become a seafloor. It does not happen all at once. The coast moves inward first, the sea advancing over the lowest lying ground, over the coastal plains and the estuaries and the shallow water habitats that had been at sea level or barely above it. The rivers that had flowed across those plains to the coast now find their mouths flooded, their lower reaches drowned, turning from rivers into estuaries, and then, as the land continues to sink, into underwater channels in the sediment of the emerging seafloor. The deltas where those rivers had deposited their sediment become submarine fans, the sediment continuing to accumulate, but now doing so on the floor of a shallow sea rather than on the surface of a coastal plain. Then the hills go. The low hills that had been inland from the coast, that had looked out over the coastal plain toward the sea, now find the sea advancing toward them. Their lower slopes are flooded first, then their middle slopes. The hilltops become islands, surrounded by the advancing water, and for a time, a geological time measured in hundreds of thousands of years, they are islands in the truest sense, separated from each other by the shallow water that has covered the former plains between them. Life clings to these islands. Whatever was on the hilltops before the flooding survives, isolated now, cut off from the populations that had lived on the lower ground. evolving in the particular and accelerated way that isolated populations always evolve when they are small enough and separated enough, and facing different conditions than their ancestors faced on the mainland. Then the islands go too. The water rises further, or rather the land sinks further, which amounts to the same thing from the perspective of the creatures trying to live on it. The islands become shallower. Their beaches are narrower. Their forests reach closer to the high tide line. And one by one, in geological time, they go under. The last trees on the last hilltop of each disappearing island are killed by saltwater intrusion into the soil long before the water actually covers them. The soil itself is washed away. The bare rock is all that remains above the surface for a time, wave-washed and eroding, before it too descends below the water and joins the rest of the drowned landscape on the seafloor. What is left behind when rock descends below the surface of the ocean is not nothing. This is important. The rock is still there. It has not dissolved. It has not been destroyed. It has simply changed its relationship to the surface of the water from above it to below it. And that change in relationship, while it feels enormous from the perspective of anything that requires air and sunlight to live, is from the perspective of the rock itself not particularly significant. The rock continues doing what rock does. It weathers slowly. It is covered by sediment. It hosts communities of organisms on its surface, different organisms than the ones that lived on it when it was above sea level. Organisms adapted to the cold and the dark and the pressure of deep water, but organisms nonetheless, living their lives in the geological patience of a seafloor that will still be here long after they are gone. The sediment is one of the most important things that happens to a drowned landscape. From the moment the seafloor forms, from the moment the last rock descends below the surface of the water, particles begin to fall onto it from above. They fall constantly, ceaselessly, with the patient arithmetic of accumulation. They are the shells of microscopic organisms that lived in the sunlit upper waters of the ocean and died and sank. They are grains of dust blown from distant land surfaces and settled onto the ocean surface and slowly waterlogged and descended. They are particles of volcanic ash from eruptions that sent their products high into the atmosphere to be carried by wind across thousands of kilometers of ocean, before finally falling into the water and joining the slow rain of particles descending toward the seafloor. Each particle is small. Each one contributes an amount to the total depth of sediment that is too small to measure individually. But time is patient, and the ocean covers a great area, and the particles never stop falling. Layer by layer, millimeter by millimeter, over tens of millions of years, the sediment accumulates on the surface of the drowned continent. It covers the old riverbeds. It fills the old valleys. It smooths over the roughness of the drowned landscape, burying the evidence of what was there before under meters and then tens of meters and then hundreds of meters of accumulated geological time. The sediment is a record. This is the extraordinary thing about it. Every layer is a chapter. Every change in the composition of the sediment, every shift from one type of particle to another, every variation in the chemistry of the material, tells something about the conditions that existed in the ocean above at the time that layer was deposited. The fossils in the sediment, the shells and the teeth, and the hard parts of organisms that lived and died in the water above the seafloor, are a biological record of what was alive in that part of the ocean at that time. The geochemistry of the carbonate shells tells the temperature of the water in which those organisms lived. The presence or absence of certain types of organisms tells the depth of the water, the nutrient conditions, the proximity to land sources of sediment. When scientists drill a core through the sediment on the floor of the ocean above Zealandia and pull up a cylinder of compressed geological time and lay it out on a table and begin to examine it layer by layer, they are reading a record that goes back tens of millions of years. They are reading the history of the ocean that formed above the drowned continent. They are reading the story of the descent, told not from the perspective of the land that was descending, but from the perspective of the water that was filling the space that the land had occupied. The cores tell the story clearly. The oldest sediment above the drowned parts of Zealandia, the layers closest to the basement rock, reflects the conditions of a shallow sea. The fossils in those layers are the fossils of organisms that lived in shallow, sunlit water, organisms that require proximity to the surface to survive. Above those layers, as the continent sank and the water above it deepened, the fossils change. The shallow water organisms disappear, replaced by the organisms of deeper water, organisms adapted to cooler temperatures and lower light and higher pressure. The record in the sediment tracks the descent of the seafloor with a precision that geology rarely achieves. A slow-motion record of a continent going under, told in the language of the organisms that lived above it as it went. It took approximately 30 million years for most of Zealandia to go from land surface to seafloor deep enough that the shallow water organisms in the sediment record are replaced by deep water ones. 30 million years is not a long time in the history of the Earth, but it is an incomprehensible time by any human measure. 30 million years ago, there were no grasslands anywhere on Earth. The continents were in slightly different positions than they are now. The climate was different, warmer in the poles, more uniform across latitudes. The ancestors of horses were small, dog-sized creatures browsing in forests that no longer exist. The lineage that would eventually produce humans had not yet diverged from the lineage that would produce the other great apes. The world was recognizably the same world, the same planet with the same oceans and the same basic continental arrangement, but different in every detail that matters to the creatures that live in the details. Through all of that, through the 30 million years of biological and climatic and geographical change that separate that world from this one, Zealandia was sinking. Slowly, continuously, in its geological patience, adding layers of sediment above itself as it went, writing the record of its descent in the only language available to it, the language of rock and time and the chemistry of the ocean. There is something in this that the body understands before the mind does. The body knows about slow descents. It knows about the kind of lowering that happens so gradually you cannot catch yourself doing it, that is only visible in retrospect, that you discover not in the moment of its happening, but in some later moment when you compare where you are now to where you were before, and find the distance larger than you expected. The body knows about the weight that accumulates like sediment, layer by layer, each layer small enough to seem negligible at the time it arrives, until the accumulated weight of all the layers is suddenly and unexpectedly significant. And the body knows about what waits at the bottom of the descent. Not nothing, never nothing. Something changed, something transformed by the pressure of all that weight and all that time, something that has been becoming what it is in the dark and the depth and the patience of geological time, waiting for the conditions to be right for it to be found and read and understood. Zealandia waited. The sediment accumulated above it. The ocean moved above the sediment. The sun rose and set above the ocean, year after year after year after year, tens of millions of times, each day identical to every other day from the perspective of the drowned continent beneath, which does not experience days, does not experience the passage of time in any way that resembles experience, simply continues being what it is in the dark and the pressure and the cold of the deep ocean floor. What it is a continent. What it has always been, through the rifting and the separation and the cooling and the sinking and the long accumulation of sediment above it, is a continent. The water did not change that. The darkness did not change that. The pressure did not change that. The 85 million years of being unvisited by any creature that could have recognized it for what it was, that did not change it either. It simply waited, with the patience of things that do not know they are waiting. With the absolute consistency of physical law applied to a very large piece of rock over a very long time, with the geological equivalent of peace, and in the deep part of you that is also descended, also submerged, also waiting in the quiet dark of this particular night for the surface to return, you recognize that patience. You know it. Not from having read about it, not from understanding the geology, but from the body's own experience of the slow descents, the long waitings, the deep and necessary rest that comes after a day that asked too much and a world that keeps asking. The descent is not the end of the story. For Zealandia, it was the middle. The long, quiet, sediment-covered middle, where everything that would happen next was being prepared in the dark. Rest in that middle. It is not nothing. It is where the real work gets done. What remains? When something very large goes under the water, it does not disappear. This seems obvious when you say it. Of course it does not disappear. Matter does not cease to exist because water covers it. The laws of physics do not make exceptions for large objects that would be more convenient to simply eliminate than to accommodate beneath an ocean. What goes under the water stays under the water, in whatever form the water and the time and the pressure have shaped it into, waiting with the absolute patience of things that do not experience waiting. But there is a difference between knowing this and feeling it. Between understanding intellectually that Zealandia is still down there, all 4.9 million square kilometers of it, and actually allowing yourself to sense the presence of something that vast sitting beneath kilometers of water, present and real and structured, shaped by the same forces that shaped every other landscape on the surface of the earth, only doing so in the dark and the cold and the silence of the deep ocean floor. 4.9 million square kilometers. Hold that number for a moment, not as an abstraction but as a size. Greater India is approximately 4.4 million square kilometers. The subcontinent, with its Himalayas and its plains and its rivers and its coastlines, with all the geographic complexity that has supported one of the largest concentrations of human civilization on Earth for thousands of years, is smaller than Zealandia. Australia is approximately 7.7 million square kilometers, making it the smallest continent by most measures, and yet even Australia is only about 60% larger than the submerged continent sitting in the ocean to its east. Zealandia is not a small thing that happened to sink. Zealandia is a continent-scale feature of the Earth's surface, continent in every geological sense, only existing at a depth that makes it invisible to any survey that does not deliberately look beneath the water. And beneath the water, it has a shape, a real shape, as complex and varied as the surface of any other continent, with its own mountain ranges and its own basins and its own plateaus and its own deep trenches where the plate boundaries cut through it. The shape is not random. It is the accumulated result of everything that has happened to this piece of crust since it separated from Gondwana. Every tectonic event and every erosional process and every volcanic intrusion and every episode of compression and extension that has deformed and reformed the rock over 85 million years of geological history. The shape is a record, and the record, read by people with the right instruments and the patience to read it, tells an extraordinary story. Begin at the south. The southernmost portion of Zealandia is a broad, relatively shallow platform called the Campbell Plateau. It extends south and east from the South Island of New Zealand, a vast underwater tableland sitting at depths between 800 and 1,000 meters below the surface of the ocean. These are not abyssal depths. This is not the floor of the deep ocean, the kilometers-deep basins where the oceanic crust sits, where the pressure crushes the body of any organism not specifically adapted to it, and where the temperature hovers just above freezing and the darkness is absolute. The Campbell Plateau is relatively shallow in oceanic terms, a high place on the drowned continent, a plateau in the truest sense, elevated above the surrounding seafloor the way a plateau is elevated above the surrounding lowlands on any continent's surface. The Campbell Plateau was once above the water. The evidence is in the rock, in the sediment that covers it, in the fossils preserved in that sediment. The oldest layers of sediment on the Campbell Plateau contain the remains of organisms that lived in shallow water, near-surface organisms that required sunlight to survive. These organisms are now found at depths of nearly a kilometer, sitting in rock that was once close enough to the surface for their light-dependent biology to function. The rock has not moved. The organisms have not moved. The water above them has deepened as the plateau sank, and the record they left in the sediment before the sinking carried them too deep for light to reach is preserved there. Readable, a testimony to what this place once was. Move north from the Campbell Plateau and you cross a deeper section, a submarine valley that cuts through the drowned landscape the way a valley cuts through any landscape, following the path of least resistance, the low point in the terrain through which water and sediment preferentially move. Then the terrain rises again, onto the next major feature of the drowned continent, the structure that geologists call the Chatham Rise. The Chatham Rise is a submarine ridge, an underwater mountain range oriented roughly east to west, extending from the east coast of the South Island of New Zealand out into the Pacific for roughly 1,600 kilometers. It rises from the surrounding seafloor to depths of between 200 and 400 meters at its shallowest portions, close enough to the surface that the light still reaches it, close enough that the communities of organisms living on its peaks are very different from the communities living on the deeper parts of the seafloor. The Chatham Rise is an undersea mountain range that the ocean has covered but not entirely subdued. It is still a ridge. It still organizes the flow of deep ocean currents. It still creates conditions at its peaks that are different from conditions at its flanks, different enough to support distinct ecological communities, different enough to matter to the biology of the ocean above it. At the western end of the Chatham Rise, where it meets the eastern coast of New Zealand, the underwater terrain rises above sea level for the first time. The mountains of the South Island of New Zealand are the exposed peaks of Zealandia, the portions of the drowned continent that were uplifted by the collision of the Pacific and Australian plates to a height sufficient to break the surface of the ocean. They are not separate from the submerged continent. They are the same piece of crust, continuous with the Campbell Plateau to the south and the Chatham Rise to the east, connected by the same basement rock, part of the same geological body. They are simply the highest part of it, the part that stuck up above the water when the rest went under, the peaks of a drowned mountain range that have since been uplifted further by tectonic forces, raised high enough to have glaciers and snowfields, and the particular sharp-edged beauty of mountains young enough to still be steep. The Southern Alps, those dramatic mountains that run the length of the South Island, that are visible from the Tasman Sea to the west and from the Pacific to the east, are Zealandia's highest points. They are what a continent looks like when you can see only its tallest peaks above the water. If you stood on the summit of Yooraki, Mount Cook, the highest peak in New Zealand at 3,700 meters, and looked in every direction, you would be looking at the visible surface of a continent that is 94% invisible. You would be standing at the top of something far larger than the island beneath your feet suggests. You would be at the summit of the 8th continent. Below the South Island, below the North Island, below the shallow shelf that surrounds both of them, the continent extends into the sea in every direction. The continental shelf that immediately surrounds New Zealand is just the most shallow part of the drowned landscape, the portion closest to sea level, the portion where the water is shallow enough to let light reach the bottom, and where the biological productivity is high enough to support the fisheries that have been economically important to New Zealand for as long as people have been fishing its waters. This shelf is Zealandia. The people fishing its waters are fishing above a continent. Continue north from New Zealand, across the deeper water of the central portion of the drowned continent, and the terrain eventually rises again toward the northern edge of Zealandia. Here, at the northern extreme of the continent, there is another platform, shallower than the surrounding deep ocean, elevated above the abyssal floor, carrying on its surface the sediment of tens of millions of years of accumulation. And at the northern end of this platform, breaching the surface of the ocean in the way that the Southern Alps breach it in the south, there are islands, the islands of New Caledonia. New Caledonia is the second place where Zealandia shows itself above the water. It is a long, narrow island, roughly 400 kilometers from end to end, sitting in the southwestern Pacific Ocean north of New Zealand and northeast of Australia. It is surrounded by one of the largest lagoons in the world, enclosed by a barrier reef that is the second longest in the world after the Great Barrier Reef of Australia. The lagoon exists because the shallow shelf of Zealandia's northern platform provides the kind of shallow, warm, sunlit water that coral reefs require. The reef is not coincidental. The reef is there because Zealandia is there, because the drowned continent created the shallow underwater terrain on which the coral could establish itself and build and grow into something large enough to be visible from orbit. New Caledonia has a geology that is unlike almost anything else on Earth. It has ultramafic rocks, rocks from the deep mantle, rocks that were once far below the surface of the Earth and were pushed up through the crust by tectonic processes and now form the surface of the southern portion of the island. These rocks are rich in nickel and chromium and cobalt, the elements of the deep Earth, and they have given New Caledonia one of the largest nickel deposits on the planet. The nickel comes from Zealandia's geological history, from the particular sequence of tectonic events that brought mantle material to the surface and preserved it there, a treasure in the rock that has been sitting in the southwestern Pacific, partly visible and partly submerged, since before any human being knew there was a Pacific Ocean to sit in. Between New Zealand in the south and New Caledonia in the north, between the Campbell Plateau and the northern platform, the interior of the drowned continent is a complex landscape of ridges and basins and volcanic features and sediment-filled lowlands. There are extinct volcanoes on the seafloor of Zealandia, submarine peaks that once erupted and built themselves upward toward the surface, and then, when the magma supply was cut off, ceased to grow and were carried down by the sinking of the continent around them. Some of these volcanic peaks, called seamounts, rise high enough from the surrounding seafloor to create their own local environments, their own ecological communities of organisms that live on and around the hard volcanic rock in the otherwise flat expanse of sediment-covered seafloor. There are also, in the deeper portions of the continent, the traces of the ancient river systems. The rivers that once ran across the surface of Zealandia, before it sank, carved valleys in the landscape the way rivers always do, following the downhill path, cutting into the rock, depositing their sediment loads in deltas at the coast. When the land sank and the rivers were drowned, the valleys they had carved were covered by the sea. But they were not erased. They were buried under sediment, preserved in the rock beneath the ocean floor the way a cast preserves the shape of whatever was pressed into it. Scientists mapping the seafloor above Zealandia with sonar can sometimes detect the buried traces of these ancient river systems, the ghost valleys of a landscape that ceased to exist tens of millions of years ago, still legible in the rock if you know how to read it. This is what remains, not nothing, not a featureless void. A continent with all the structural complexity that the word implies, preserved beneath the water, mapped now in sufficient detail to confirm what it is, known now in a way it was not known before, real in the way that things are real when the instruments finally catch up to them, and the data finally resolve into a shape that can be named. What remains is the shape of a thing that went under and kept being itself. That sank and did not stop being a continent. That was covered by water and darkness and millions of years of accumulated sediment, and did not, in any geological sense, cease to exist. It simply became a different kind of presence, a presence beneath the surface, a presence that required new instruments and new patience and a willingness to look where looking is difficult before it could be found and recognized and added to the count. We thought there were 7. The instruments said 8. And the 8 has been there the whole time, waiting in the particular way that very large and very patient things wait, which is to say not waiting at all, but simply being in the dark and the depth and the cold, what it has always been. Consider for a moment what it means that we did not know. Not as a failure, not as an indictment of the history of science or the inadequacy of any particular method of investigation. Simply as a fact, a remarkable and somehow consoling fact. The world is still larger than our knowledge of it. The map is still incomplete. There are still things waiting to be recognized, waiting for the right question to be asked in the right way with the right instruments, waiting with the absolute patience of geological features that do not know they are waiting, that simply are, beneath the surface of what we have so far managed to see. If a continent can remain unknown for the entire duration of human civilization, hidden not in some inaccessible corner of the universe, but beneath the ocean of the planet we live on, the planet we have been sailing across and fishing from, and mapping and studying for thousands of years, if something that large can remain unrecognized for that long, then the question of what else remains unrecognized becomes not a source of anxiety, but a source of something closer to wonder. The world keeps offering more than it has already given. The map keeps needing to be redrawn. The count keeps turning out to be one higher than we thought. There is always something more beneath the surface. There is always a shape in the dark that the instruments have not yet reached, a structure in the deep that the questions have not yet been precise enough to find. The discovery of Zealandia is not the last such discovery. It is the most recent one. And the most recent one always points toward the next, toward the thing that is sitting beneath whatever surface we are currently looking at, patient and present and real, waiting for the moment when the curiosity and the instruments and the willingness to look in the right place at the right time finally coincide. You are beneath the surface now. The continent is around you and below you, and present in the dark the way that all large and patient things are present, not announcing themselves, not demanding attention, simply being what they are in the deep and the quiet, and the particular kind of peace that exists in places where the noise of the surface has not yet reached. The surface is far above you. The light from the surface is a different light than it was when you began. Dimmer, more diffuse, filtered through kilometers of water into a blue so deep it is almost not blue at all, almost not a color, almost simply the quality of being in a place where light arrives as a rumor rather than a fact. Rest in the blue. It is the color of depth. It is the color of the ocean above a drowned continent. It is the color that light becomes when it has traveled far enough from its source to arrive changed, gentled, carrying only what it can carry at this distance, which is enough. Which has always been enough. What remains is vast. What remains is real. What remains is here. The scientists who found it. Discovery is rarely what the stories make it out to be. The stories prefer a single moment. A ship at the edge of the known world. A coastline materializing from the fog. A scientist in a laboratory at 3 in the morning when the experiment finally produces the result that changes everything. The stories prefer drama because drama is easier to remember than the truth, and the truth of how discovery actually works is slower and more collaborative and less cinematic than any single moment of revelation can capture. The truth is that discovery is almost always a process. A long, slow, iterative process of accumulation, of data gathered over years and decades by different people with different instruments for different purposes, of results that sit in archives and journals and filing cabinets, until someone with the right question comes along and asks it in a way that causes the accumulated data to reorganize itself into an answer that was always there, always implicit in the numbers, waiting for the question that would make it visible. The discovery of Zealandia was exactly this kind of discovery. It did not happen in a single moment. It happened over decades, in the patient and unglamorous work of scientists mapping the seafloor and drilling rock cores, and measuring the gravitational field of the ocean, and analyzing the composition of the rock beneath the water and slowly, carefully, building the case that what they were looking at was not what the map said it was. That the floor of the southwestern Pacific Ocean was not simple oceanic crust of the kind found throughout the deep ocean basins. That it was something thicker, something more buoyant, something that had the geological signature not of oceanic crust, but of continental crust, stretched and thinned and drowned but continental nonetheless. The scientists who did this work were not famous. They are not famous now, not in the way that scientists who make dramatic discoveries in physics or medicine sometimes become famous, not in the way that explorers who reached dramatic places became famous in earlier centuries. They are geologists and geophysicists, people who have spent their careers thinking about rock and time and the slow movements of the Earth's plates, people who find in the patient accumulation of geological data a satisfaction that does not require public recognition to sustain it. They did the work because the work needed doing, and because they were the people positioned to do it, and because the data kept suggesting something that the maps had not yet acknowledged. Nick Mortimer is one of them. He works at GNS Science in New Zealand, the government research institute that studies the geology and geophysics of the New Zealand region and the ocean around it. He has spent years, decades, thinking about the rock beneath the southwestern Pacific, thinking about the way it is distributed and how thick it is, and what its composition tells you about its history. He is the kind of scientist who talks about geological features the way other people talk about familiar landscapes, with the easy familiarity of someone who has spent enough time with something to know it well, to know its character, to be able to say things about it that require not just knowledge, but a kind of intimacy with the subject that only comes from sustained attention. When Mortimer talks about Zealandia, he talks about it as though it is obvious. Not obvious in the sense of simple or easily seen, but obvious in the retrospective sense, in the sense that once you have seen it, you cannot understand how it was missed. The data were there. The measurements of crustal thickness that showed the crust beneath the southwestern Pacific was too thick to be oceanic crust. The gravitational measurements from satellites that showed the subtle variations in the Earth's gravitational field that indicate the presence of continental density rock beneath the ocean floor. The rock cores drilled from the seafloor that contained granite and metamorphic rock types that form in continental crust and not in oceanic crust, rock that had no business being on the floor of the Pacific Ocean if the floor of the Pacific Ocean was simply oceanic crust all the way down. The data were there. What was needed was someone to put it all together, to look at the accumulated measurements from decades of research and ask the question that the data was waiting to be asked. Not what kind of oceanic crust is this, but is this oceanic crust at all? And if it is not oceanic crust, what is it? And if it is continental crust, then what does that make the feature it forms? The paper that answered those questions was published in February of 2017 in GSA Today, the Journal of the Geological Society of America. Its title was careful, almost understated in the way that scientific titles often are when the claim being made is large enough that the authors are aware of the burden of proof required to support it. We should recognize Zealandia as a drowned continent. Not we have discovered a new continent, not announcement of the eighth continent, simply a recommendation, a suggestion that the geological community update its terminology to reflect what the data already showed. We should recognize the continent was already there. The recognition was what was new. Mortimer was the lead author. His co-authors were 10 other scientists, geologists and geophysicists from New Zealand and New Caledonia and Australia, people who had been working on different pieces of the same puzzle for years, and who came together to write the paper that assembled the pieces into a complete picture. The collaboration was international, and it was decades in the making, and it was, in the way that scientific collaborations often are, a reflection of the fact that the question was larger than any single research group could have answered alone. The paper made a specific geological case. It argued that Zealandia met all the criteria that geologists use to define a continent. It had continental crust, distinct in composition and density from the oceanic crust that makes up the floors of the ocean basins. It had an area large enough to qualify, at 4.9 million square kilometers, comparable in size to the smaller recognized continents. It had a well-defined elevation relative to the surrounding seafloor, elevated above the oceanic crust around it, the way continents are elevated above the oceanic crust that surrounds them. And it had a geological history that was coherent and distinct. The history of a piece of crust that had been part of Gondwana had rifted away, had thinned and sunk, and been shaped by the particular sequence of tectonic events that occurred at the eastern margin of that ancient supercontinent. The response to the paper was significant. It was covered by news organizations around the world, which surprised some of the authors, who had not anticipated that a paper in a geology journal making a technical argument about crustal classification would attract the attention of general audiences. But it did, and the reason it did is not difficult to understand in retrospect. The idea that there was a continent no one knew about, that the map of the world that everyone had memorized in school was missing a piece, that something as large as a subcontinent had been sitting beneath the ocean, unrecognized for the entire duration of human history. That idea was immediately and universally interesting to people who had no particular investment in the technical details of crustal geology. It was interesting because it was about the world being larger than anyone knew. And that kind of discovery, the discovery that the world is larger than anyone knew, is always interesting, regardless of the field it comes from. But the recognition, the public recognition, the news coverage and the attention came after the work. The work itself was quieter. It was the work of going out on research vessels in the southwestern Pacific and drilling cores through kilometers of water and sediment to reach the basement rock below. It was the work of analyzing those cores in laboratories, identifying the minerals and their compositions, determining the pressure and temperature conditions under which they formed, and what those conditions implied about the tectonic environment of their formation. It was the work of processing satellite gravity data and producing maps of the gravitational field that revealed the shape of the dense rock beneath the ocean floor. It was the work of running seismic surveys, sending sound waves down through the water and the sediment and the rock, and recording the reflections, building up a picture of the subsurface geology, the way a sonogram builds up a picture of what is inside a body. All of that work had been done by many different scientists working on many different aspects of the southwestern Pacific geology over the course of several decades. The 2017 paper was the synthesis, the moment when someone sat down with all of the pieces and said, "Here is what this means. Here is the conclusion that all of this data has been pointing toward. Here is the name for what we have been looking at without yet properly naming." There is something important in that sequence. The name came last. The thing itself had been there all along, and the data describing it had been accumulating for decades, and the understanding of its nature had been growing gradually among the scientists who worked on it. But the name came last, and the naming mattered, not because it changed the geology, not because Zealandia became a continent when it was named and was not a continent before, but because naming is how human beings make things available to the broader understanding. The unnamed thing exists only for those who know enough to see it without the name. The named thing can be known by anyone who encounters the name and asks what it refers to. Zealandia is now a word. It appears in geology textbooks and in the scientific literature, and in the databases where geographic features are cataloged and described. It appears in news articles and in encyclopedia entries, and in the conversations of people who found the discovery interesting and told other people about it. The continent has a name, and the name gives it a kind of presence in human knowledge that it did not have before, a presence that is different from its geological presence, but that is, in its own way, just as real. The scientists who found it did not set out to find it. They set out to understand the geology of the southwestern Pacific, which is a specific and technical goal that does not sound like it leads to the discovery of a continent. But the specific and technical goal, pursued with sufficient rigor and sufficient patience and sufficient willingness to follow the data wherever it leads, produced the continent. That is how science works at its best, not as a directed search for a predetermined answer, but as an open inquiry that follows the evidence toward whatever the evidence is actually pointing at, even when what the evidence is pointing at is something much larger and more surprising than anyone expected. The data was pointing at a continent. It had been pointing at a continent for decades. And in 2017, finally, the pointing became a recognition, and the recognition became a name, and the name became part of the map. The map is still incomplete. It will always be incomplete. That is not a failure of the map. It is the nature of knowledge, which grows always at the edge of what is known, which is always smaller than what exists, which is always being revised and extended and corrected by the data that the world keeps producing about itself, whether or not anyone is paying attention. The world does not wait for human beings to be ready to receive its revelations. It simply is what it is, producing data about itself continuously, in the form of rock and gravity, and the chemical composition of cores drilled from the seafloor, waiting for the instruments and the questions and the synthesizing minds to catch up. Mortimer and his colleagues caught up. In 2017, in a paper with 11 authors and a careful, technical title, they caught up to something that had been waiting since before any human being had stood anywhere on Earth and wondered about the shape of the world. Think about the patience required for that kind of work. Not the dramatic patience of waiting for a single experiment to produce a result, not the patience of a night spent watching a telescope, but the quieter and more sustained patience of a career devoted to a question that does not resolve quickly, that gives up its answers slowly and incompletely, that requires decades of accumulation before the picture is clear enough to describe. The patience of a scientist who has spent 30 years thinking about the rock beneath the southwestern Pacific and has arrived at an understanding of it that no one had arrived at before. That patience is its own kind of extraordinary. Not the extraordinary of the single dramatic moment, but the extraordinary of the long, sustained attention, the extraordinary of the person who looks at something complicated and difficult and says, "I will stay with this. I will keep asking. I will follow the data wherever it goes for as long as it takes. And eventually, if I am rigorous and patient and honest about what the data shows, I will understand something that no one has understood before." Mortimer understood something that no one had understood before. His colleagues understood it with him, and in understanding it, they gave the rest of us the gift of a larger world, a world with one more continent than we thought, a world that turned out, as it always turns out when we look carefully enough, to be bigger and more complex and more surprising than the version we had been living with. The world is always larger than the map. The scientists who found Zealandia knew that. They had spent their careers working at the edge of what the map showed, in the places where the data contradicted the accepted picture, in the uncomfortable territory where what the instruments said and what the textbooks said were not the same thing. That is where discovery lives, not in the confirmation of what is already known, but in the careful, patient, honest attention to the places where what is already known turns out not to be the whole story. There is always more to the story. There is always a continent beneath the ocean that the map has not yet drawn, waiting for the question that will finally make it visible. Breathe. The scientists who found Zealandia did their work in the daylight, in the noise and the ordinary busyness of scientific life, in conference rooms and on research vessels, and at computer screens where the data arrived slowly and was processed carefully, and was slowly transformed into understanding. But the thing they found exists in the dark. It exists in the deep and the quiet and the cold of the ocean floor, doing what it has always done, being what it has always been, indifferent to the recognition that has finally found it. You are in that dark with it now. You are in the place that the paper described, that the data mapped, that the instruments measured and the scientists named, and the news articles covered for 3 days in February of 2017 before the world moved on to the next thing and Zealandia went back to being what it has always been. Quietly, vastly, patiently present, beneath the water, beneath the surface, beneath the map, real, life in the deep. Isolation is one of the most powerful forces in biology. Not isolation in the sense of loneliness, not isolation as an experience of absence or deprivation, but isolation in the precise ecological sense, the condition of a population separated from other populations of the same species by a barrier that cannot be crossed, a mountain range, an ocean, a river too wide to swim, a stretch of inhospitable habitat too long to traverse. Any barrier that makes genetic exchange between populations impossible, that causes two groups of organisms that were once part of the same species to live out their evolutionary trajectories independently, accumulating changes that the other group does not accumulate, diverging slowly and then faster, and then completely into something new. Isolation is how new species are made. Not the only way, but one of the most reliable ways, one of the ways that leaves the clearest evidence in the biology of the organisms that resulted from it. When you find a creature unlike anything else alive on Earth, a creature whose nearest relatives are millions of years dead, a creature that seems to belong to a different chapter of evolutionary history than everything living around it, you are almost always looking at the product of a long isolation. At something that was separated from the main current of its lineage long enough and completely enough to become, in the strict biological sense, a different thing. New Zealand is full of these creatures. This is not a coincidence. It is the direct biological consequence of Zealandia's geological history, of the separation from Gondwana that carried a sample of the supercontinent's life with it into isolation, and of the subsequent drowning that reduced the habitable surface of the continent to a small fraction of what it had been, concentrating whatever survived into the islands that remained above the water. The biology of New Zealand is the biology of deep isolation on a geological timescale. It is what life looks like after 85 million years of evolving on a piece of crust that was separated from everywhere else before the lineages that now dominate the rest of the world had fully formed. Before mammals. That is the critical fact, the fact that explains more about New Zealand's biology than any other single datum. Zealandia separated from Gondwana approximately 85 million years ago. The great diversification of placental mammals, the evolutionary radiation that produced the vast majority of mammal species alive today, including every large land mammal on every continent, began approximately 66 million years ago, after the asteroid impact that ended the Cretaceous period and cleared the ecological stage for mammals to expand into the roles that the dinosaurs had vacated. Zealandia was already an island continent by then, already separated by hundreds of kilometers of open ocean from the land masses where the mammals were beginning their great diversification. The mammals never arrived, not naturally, not until human beings brought them, First the rats and the dogs that came with the Polynesian voyagers who became the Maori, and then the full catastrophic suite of introduced species that came with European settlers. The mice and the stoats and the possums and the deer and the pigs, and all the other mammals that have been transforming New Zealand's ecosystem since human arrival. But for the 66 million years between the mammalian radiation and the arrival of human beings, the land surface of Zealandia, those small islands projecting above the ocean from the drowned continent, was essentially mammal-free. What filled the ecological roles that mammals fill everywhere else? What occupied the niches that, on every other continent, were claimed by the creatures that followed the dinosaurs into ecological dominance? The answer is birds. New Zealand is a country of birds in a way that no other country on Earth has been since the Cretaceous. In the absence of mammalian predators, in the absence of the creatures that everywhere else made flying the critical survival skill for small animals, the birds of New Zealand did something that birds almost nowhere else have been able to do. They stopped flying. Not all of them, not immediately, not as a decision, but over millions of years of evolution on land where there was nothing to run from, where the energy cost of maintaining the musculature required for flight was not offset by any survival advantage. The birds that happened to be slightly less dependent on flight survived as well as the ones that flew, and their offspring inherited the tendency. And over generations, the tendency became a trait, and the trait became fixed, and the birds became something that looked like birds but did not fly. The kiwi is the most famous result of this process. A small, round, furry-looking bird that is related to the ostrich and the emu and the cassowary, that shares with them an ancient Gondwanan ancestry, that has been evolving in New Zealand for long enough to become completely unlike any of its relatives. The kiwi has no functional wings. Its wings are vestigial, reduced over millions of years of disuse to small stubs hidden under the feathers, no longer capable of generating lift, no longer needed for anything a kiwi does. It has nostrils at the tip of its long bill, unique among birds, giving it a sense of smell that it uses to find the earthworms and insects in the soil that make up most of its diet. It is nocturnal. It lays an egg that is roughly 20% of its own body weight, the largest egg relative to body size of any bird on Earth, because its chicks hatch already large and capable, already prepared to survive in a world that the kiwi's long isolation has made safe enough for them. The kiwi has been on Zealandia for approximately 60 million years. For 60 million years, across the entire span of time since the dinosaurs disappeared, the kiwi lineage has been living on these islands, evolving in the particular direction that 60 million years of island isolation pushes things, becoming more itself, becoming less like anything anywhere else, becoming the distilled biological product of a geological history that was unlike any other geological history on Earth. Then there is the tuatara. The tuatara is not a lizard. It looks like a lizard. It lives the life of a lizard. It occupies the ecological niche of a lizard, but it is not a lizard. It belongs to a separate reptile order, the Rhynchosphalia, that was once distributed across much of the world, and that is now found in a single living genus, in a single country, on the small rocky islands off the coast of New Zealand where the tuatara has managed to survive. The tuatara's nearest relatives are all extinct. They have been extinct for approximately 60 million years. The tuatara is the last survivor of a lineage that the rest of the world lost when the conditions that had maintained it changed, and nothing came to fill the role that the Rhynchosphalia had occupied. In New Zealand, the conditions did not change. In New Zealand, isolated on its piece of drowned continent, protected by the ocean that the mammals could not cross, the tuatara's lineage survived. Survived and barely changed, evolved at one of the slowest rates of any vertebrate lineage on Earth, maintained by the consistency of the conditions it found itself in, the consistency of an island environment that stayed much the same for tens of millions of years because the isolation that was responsible for its strangeness was also responsible for its stability. The tuatara has a third eye. On the top of its head, beneath the skin, is a structure with a lens and a retina and a connection to the brain, a photoreceptive organ that is sensitive to light but does not form images, that is covered by scales in adults, and is thought to function primarily in the hatchling's early weeks to help it regulate its exposure to sunlight. The third eye is real. It is documented. It is present in the anatomy of every tuatara, a structure inherited from an ancestor that lived before the lineage of mammals, and the lineage of lizards had fully diverged, a feature so ancient that its presence in a living animal is the biological equivalent of finding a working example of a technology that everyone thought had been extinct for 60 million years. The kakapo is something else entirely. It is a parrot, the heaviest parrot on Earth, so heavy that it cannot fly despite having wings that are fully formed and feathered, despite having the body plan of a bird that once flew and that retains all the structural features of flight except the ability to actually perform it. The kakapo is nocturnal, like the kiwi. It is a herbivore, eating the leaves and bark and fruit of the forest floor. It is extraordinarily long-lived, capable of surviving for almost a century, which gives it the longest lifespan of any bird on Earth. It is also almost extinct, reduced by the introduction of mammalian predators to a population that has, at various points in the recent past, numbered in the dozens. The kakapo evolved in the absence of mammalian predators. When stoats and rats and cats arrived with human beings, the kakapo had no behavioral response to them. It had not evolved the reflexes of a creature that needs to flee from terrestrial predators, because, for the millions of years of its evolutionary history, there had been no terrestrial predators to flee from. It froze when threatened, a strategy that works perfectly well against birds of prey that hunt by movement, but that is catastrophically ineffective against a stoat, which finds the motionless kakapo by smell. The biology that had been shaped by 60 million years of isolation was not prepared for the world that arrived in the last 1,000 years. This is one of the tragedies of Zealandia's biological heritage. The creatures that the long isolation produced, the creatures that are unlike anything else alive, the biological treasures of a continent that evolved separately for longer than most animal lineages have existed, are precisely the creatures most vulnerable to the conditions that human beings introduced. The isolation that made them extraordinary also made them defenseless. The 60 million years that shaped them into things found nowhere else on Earth also left them unprepared for the things that everywhere else on Earth is full of. The conservation effort in New Zealand to protect these species is one of the most intensive in the world. Island sanctuaries from which introduced predators have been eradicated, captive breeding programs, translocation programs that move endangered species to predator-free islands where they can breed and build their populations without the constant pressure of animals that their biology never learned to fear. The kakapo population, which fell to fewer than 50 individuals at its lowest point, has been growing under intensive management, the result of a conservation program that treats each individual bird as irreplaceable, which it is, which every individual of a species that exists nowhere else on Earth inevitably is. The birds of New Zealand are biological time capsules. They carry in their bodies the evidence of a geological history that cannot be read directly from the rock, because the rock is underwater, and the isolation that the water represented lasted for so long that its biological consequences are more legible than its geological ones. When you look at a kiwi, you are looking at 60 million years of island isolation made flesh. When you look at a tuatara, you are looking at a lineage that the rest of the world lost before the Rocky Mountains were built. When you look at a kakapo, you are looking at what a parrot becomes when it has 60 million years to become something other than what parrots are everywhere else. And beneath the surface of the ocean, on the drowned portions of the continent, the biological story continues in a different key. The seafloor of Zealandia, the 94% of the continent that is underwater, is not lifeless. It is not the sterile desert that the term seafloor might suggest to someone who has never thought carefully about what lives in the deep ocean. It is a habitat, complex and structured, and inhabited by communities of organisms that have adapted to the particular conditions of life on a submarine continental shelf. The shallow portions of the Zealandia seafloor, the parts that are close enough to the surface for light to reach, are among the most biologically productive regions of the southwestern Pacific. The Chatham Rise, that submarine ridge that extends east from New Zealand, sits at depths where the interaction of ocean currents creates the conditions for exceptional biological productivity. Cold, nutrient-rich water from the deep ocean is pushed upward along the slopes of the rise, bringing with it the dissolved minerals and compounds that form the basis of the ocean food web. The phytoplankton that live in the sunlit surface waters above the rise bloom in these nutrients. The zooplankton that eat the phytoplankton are abundant. The fish that eat the zooplankton are abundant. The Chatham Rise is one of the most important fishing grounds in the southern hemisphere, and it is a fishing ground precisely because Zealandia is there beneath the water, shaping the ocean currents above it, creating the conditions that make the water above it unusually rich. The deeper portions of the Zealandia seafloor, the parts where light does not reach, where the pressure is higher and the temperature is colder, and the conditions of life are more extreme, host different communities. Corals, not the reef-building tropical corals of shallow water, but the deep-water corals that live without photosynthesis, that build their skeletons from the dissolved calcium in the seawater around them and grow very slowly in the cold dark, colonize the hard rock surfaces where sediment has not covered everything. Sea stars and brittle stars move across the sediment. Fish adapted to the pressure and the dark navigate by senses that do not depend on light. Organisms that have never been described by science, species new to biology, live in the deep communities of the Zealandia seafloor and wait for the expeditions that have not yet reached them. The ocean above Zealandia is not an absence. It is a presence, biological and complex, and organized by the shape of the drowned continent beneath it, by the submarine ridges and plateaus and basins that structure the flow of the water and create the conditions that determine what can live where. Zealandia shapes the ocean above it the way any landform shapes the environment around it, not by being visible or accessible, but simply by being present, by having mass and shape, and the particular arrangement of rock and sediment that interacts with the water moving across it and the currents moving through it. Below you now, in the dark and the depth, The organisms of the Zealandia seafloor are going about their lives in the patient way of things that do not experience their lives as anything other than the immediate. The coral is growing, one microscopic skeleton at a time, building toward a structure that will take centuries to achieve any visible size. The fish are moving through the dark, following the chemical gradients that tell them where food is likely to be found. The microorganisms in the sediment are cycling the nutrients that everything else depends on, doing the invisible chemical work that makes all other life in the ocean possible. The continent is not empty. The continent is full of the accumulated biological consequence of 85 million years of isolation and adaptation, full of the species that the long separation produced on the islands above the water, full of the communities of organisms that have colonized the drowned surface below the water, full of the life that the ocean above it generates and sustains by virtue of the continent's shape and depth and position in the current systems of the southwestern Pacific. It is all here. In the dark, in the depth, in the patient continuity of biological processes that have been running without interruption since before the continent finished sinking, since before the first Polynesian canoe reached the islands that remained above the water, since before any human being knew that what they were standing on was the peak of something much larger than it appeared. Rest now in the knowledge of it. The life in the deep does not know it is remarkable. The tuatara on its rocky island does not know it is a 60-million-year-old survivor of a lineage the rest of the world lost. The coral on the Zealandia seafloor does not know it is growing on a drowned continent. They are simply doing what they do in the places where they are, with the absolute consistency of organisms following the imperatives of their biology in the environments they have adapted to. That consistency is its own kind of beauty. The beauty of life continuing in the dark, in the depth, in the cold, in the isolation, without requiring recognition or understanding or any awareness beyond the immediate awareness of the next moment, the next nutrient, the next breath of water through the gills. Continue quietly in the dark. The deep has been doing this for longer than you have been alive. It will continue long after. And in the continuity, in the patient and unhurried persistence of life in places where life has no business being as abundant and as complex and as beautiful as it is, there is something worth knowing, not knowing about, knowing, in the body. In the way the breathing continues without instruction, in the way the heart keeps its rhythm without being asked, in the way the deep processes of a sleeping body do their work in the dark without requiring any direction from the part of you that directs things when you are awake. Life in the deep, life in the dark, life continuing below the surface in ways that the surface cannot see. This is what Zealandia holds. This is what the ocean holds above it. This is what the night holds around you now. Breathe into it. You are part of it. You have always been part of it. The deep is not somewhere else. The deep is here. What Zealandia tells us. Every discovery is two things at once. It is the thing that was found, the specific object or feature or fact that did not exist in human knowledge before the moment of discovery and exists in it afterward. And it is what the finding of that thing reveals about the nature of finding, about the process of knowledge itself, about the relationship between what is known and what is real, which are never the same thing and which are always, in every field of human inquiry, separated by a gap whose size we consistently underestimate. Zealandia is both of these things. It is a continent, a specific piece of continental crust with a specific geological history, and a specific location on the floor of the southwestern Pacific Ocean. And it is also a revelation about the gap, about how large the gap can be. about how long something can exist without being known, how patient the unknown is, how completely the world can exceed the maps we have made of it without giving any obvious indication that this is the case. A continent, hidden in plain sight. Not in some inaccessible corner of the universe, not on the far side of a black hole, or in the quantum foam of subatomic space, or in any of the genuinely exotic territories that physics has revealed to be part of the structure of reality. Sitting in the ocean that human beings have been sailing across for thousands of years, fishing in for thousands of years, studying systematically for hundreds of years, mapping with increasingly sophisticated instruments for decades. The ocean that surrounds New Zealand, a country with a sophisticated scientific establishment and a deep cultural relationship with the sea. The ocean that has been covered by ships and satellites and research vessels and submersibles, that has been measured and sampled and surveyed in more ways and more thoroughly than any comparable feature of the Earth's surface. And beneath all of that attention, undetected for the entire span of human civilization, a continent. This should recalibrate something. Not catastrophically, not in a way that undermines confidence in the scientific enterprise or in the human capacity to understand the world. Science found Zealandia, eventually, precisely because the scientific enterprise has developed the instruments and the methods and the collaborative infrastructure to find things that cannot be found any other way. The discovery of Zealandia is a success of science, not a failure. But it is a success that contains within it a humbling message about the scale of what science has not yet found, about the size of the gap between the map and the territory, about the patience required to take seriously the possibility that the world is always larger than whatever description of it we currently hold. The message is not that we should distrust what we know. The message is that we should hold it with the appropriate lightness, with the awareness that every description of the world is a description of the world as it appears to the instruments and the methods available at the time of the description, and that better instruments and better methods consistently reveal that the world is more complex and more surprising and more various than the previous description suggested. This has been true in every field of inquiry, in every century, in every culture that has pursued systematic knowledge of the natural world. The world keeps being larger than the description. The description keeps needing to be revised. Zealandia tells us this in geological terms, in the terms of rock and water and time. But the lesson is not geological. The lesson is epistemological, which is a word that refers to the study of knowledge itself, to the question of what we can know and how we can know it, and what the limits of our knowing are. The lesson is about the relationship between the map and the territory, between the model and the reality, between the description and the thing being described. The map said 7 continents. The territory had 8. The map was wrong not because the cartographers were careless, or the geographers were lazy, or the scientists were negligent. The map was wrong because the instruments available at the time the map was made could not detect what was beneath the water. The wrongness of the map was a product of the limitations of the instruments, not a product of any failure of the people using them. And this is always how maps are wrong, when they are wrong, not through negligence but through the unavoidable limitations of whatever methods of inquiry are available, limitations that subsequent methods will overcome and that subsequent discoveries will reveal. Think about what this means for everything else. For every field of inquiry in which the instruments are still limited, in which the questions have not yet been asked with sufficient precision, in which the data are still accumulating toward a synthesis that has not yet been written. The fields where the map is most incomplete are almost always the fields where the territory is most interesting, where the gap between what is known and what exists is widest, and where the next synthesis, when it comes, will be most surprising. The ocean floor is one of those fields. Less than 20% of the world's ocean floor has been mapped with the resolution that would allow features the size of Zealandia's submarine ridges and plateaus to be clearly defined. The rest has been mapped at lower resolution, with sonar systems that reveal the broad outlines of the terrain but miss the detail. What else is down there, in the 80% of the ocean floor that has not yet been mapped in detail, waiting with the patience of Zealandia for the instruments to reach it and the questions to be asked with sufficient precision? No one knows. That is precisely the point. No one knows what is in the gap, which is why the gap is still a gap, why the map is still incomplete, why the territory keeps exceeding the description. This is not distressing. This is one of the most exciting facts about the current state of human knowledge. There is still so much to find. The ocean alone, which covers 71% of the Earth's surface and has an average depth of nearly 4 kilometers, is a territory so vast and so incompletely explored that every expedition to its deeper portions returns with organisms and features and phenomena that have never been described before. Every time human technology extends its reach into the deep ocean, it finds something that the previous reach did not find. Not because we were not looking, but because the territory is larger than the reach. Zealandia also tells us something specific about the definition of a continent, which turns out to be a more interesting question than it appears. You might think the definition of a continent would be settled, that 7 continents would be the kind of fact so basic and so long established that it would be beyond revision, that the definition used to arrive at 7 would be clear enough and robust enough to have anticipated any possible 8th. But the definition of a continent is not, it turns out, a settled matter. It is a matter of scientific judgment, of deciding which of several possible criteria to apply and how strictly to apply them, and what to do about the cases that fall at the edge of the criteria. The most common definition uses a combination of factors. Continental crust, as distinct from oceanic crust, in terms of its composition and density and thickness. A minimum size, large enough to constitute a distinct geological entity rather than a fragment of a larger one. A sufficient elevation above the surrounding seafloor to distinguish it from the oceanic crust around it. And a geological coherence, a unity of history that makes it meaningful to treat the region as a single feature rather than as a collection of unrelated fragments. By all of these criteria, Zealandia qualifies. Its crust is continental. Its area is continent scale. Its elevation above the surrounding oceanic crust is consistent and measurable. Its geological history is coherent, a single story of separation and subsidence and tectonic deformation that applies to the whole region. The criteria, applied honestly and without the bias of prior expectation, produce the answer that Mortimer and his colleagues argued for in 2017. Zealandia is a continent, but the application of the criteria required a decision that the criteria mattered more than the precedent. A decision that what the evidence said was more important than what the maps had always shown. A decision to revise the description in the direction of the territory, rather than to fit the territory into the existing description. That decision is not automatic. It is not forced by the data alone. The data requires interpretation, and interpretation requires judgment, and judgment is a human activity that is always subject to the pull of the familiar, to the comfort of the established picture, to the preference for the map we have always used over the map that the evidence actually supports. The scientists who found Zealandia made the right judgment. They let the evidence lead. They followed the data to its conclusion, even when the conclusion was something as surprising as a new continent, something that required revising one of the most basic facts that every school child in the world has been taught: the count of the continents. 7 is no longer the right answer. 8 is the right answer, and 8 was always the right answer. The territory always had 8. It was only the description that had 7. What else do our descriptions have wrong? What else is the territory quietly, patiently exceeding? What other 8s are hiding in the 7s of our current maps, waiting for the instruments to improve and the questions to sharpen, and someone with the patience of Nick Mortimer to sit down with all the data and say, "Here is what this actually shows. Here is the conclusion we have not yet been willing to draw. Here is the thing we should recognize." There will be more. There will always be more. The world does not run out of ways to exceed our descriptions of it. It simply waits in the geological patience of drowned continents and deep ocean floors and the vast uncharted territories of every field of inquiry that has not yet found its Zealandia. For the moment when the instruments finally reach far enough and the questions finally sharpen enough, and the minds willing to synthesize the evidence finally sit down and write the paper. Zealandia also tells us something about time, about the difference between geological time and human time, between the scale on which the Earth operates and the scale on which human consciousness operates, between the patience of rock and the impatience of awareness. 85 million years. The continent has been sinking and sitting and accumulating sediment for 85 million years. Human beings have been asking questions about the shape of the world for perhaps 100,000 years, which is less than 0.1% of the time Zealandia has been under the water. The continent waited, in its geological indifference to whether it was known or unknown, for the entire span of human existence, and then some more. It will continue to wait, in that same indifference, long after the last human being who ever asks a question has asked the last question. The rock does not care about the knowing. This is important. The rock does not require recognition to be real. It does not become more of a continent because we have named it, or less of one because we missed it for so long. It simply is what it is, with the absolute consistency of physical law applied to a particular arrangement of matter, indifferent to the human categories that we apply to it, and indifferent to the human timescales on which we apply them. This indifference is not cold. It is not alienating. It is, in its own way, a relief. The world does not depend on our attention to continue being what it is. The Zealandia seafloor does not need to be known to exist. The tuatara does not need to be understood to survive on its rocky island. The deep-water corals on the Chatham Rise do not need to be described to keep growing. The world is self-sustaining in a way that has nothing to do with our awareness of it. And this self-sustaining quality, this absolute independence of the territory from the map, is one of the most stabilizing facts available to a mind that sometimes needs to be reminded that the world does not depend on it. The world existed before you. It will exist after you. In the interval between those two facts, it is offering you the experience of being in it, of being one of the aware nodes in a universe that is mostly not aware of itself, of being the place where the rock and the ocean and the 85 million years of geological history come into contact with something that can know about them and find them extraordinary. That is not nothing. That is, in fact, everything. You are lying in the dark on a planet that has a drowned continent in its ocean that no one knew about until 2017. You are lying in the dark on a planet that is still, in the most literal geological sense, full of surprises. You are lying in the dark on a planet that has been operating on timescales and at scales of complexity that dwarf anything human consciousness can hold for long without the help of numbers. And yet human consciousness, your consciousness, is here, holding it or holding the edge of it, the part that fits into awareness, the outline of the thing that the numbers describe in full. That outline is enough. It does not need to be the whole thing to be worth having. The sliver of understanding that a human life can accumulate about the geological history of the planet it lives on is a genuine and real thing, even though it is a tiny fraction of what the planet's geology actually contains. The knowing that the instruments have so far made possible is genuine and real, even though it is a tiny fraction of what there is to know. The map is worth making and using and living by, even though the territory always exceeds it. Because the map is all we have to navigate by, and navigation is what we are here to do, moving through the territory as accurately as the map allows, revising the map when the territory reveals the map to be wrong, finding the Zealandias that are waiting in the description we currently hold, adding them to the count, drawing them in. One more continent than we thought, one more extraordinary feature of a planet that keeps being more extraordinary than the version of it we carry in our heads. One more reason to hold the description lightly and the territory with wonder. The territory is vast. The dark is deep. The continent is beneath you and around you and present in the specific, real, geological way that only things that have been around for 85 million years can be present. Feel the weight of that presence, not as a burden, as a ground. The ground of something so old and so large and so indifferent to anything except continuing to be what it is that resting on it, even metaphorically, even in the imagination, feels like resting on something that will not shift. Something that has already outlasted everything that has ever tried to outlast it. Something that will still be here, beneath the ocean, patient and present and real, long after the instruments that found it have been replaced by better instruments, and the paper that named it has been cited 10,000 times, and the scientists who wrote it have been forgotten by anyone, except the people who read the citation carefully enough to look up their names. The continent does not care about any of that. It is simply here. And for tonight, for this dark, for these slow and deepening hours of rest, simply being here is enough. It has always been enough. Rest in the territory. The map can wait until morning. The eternal rest. There is a kind of rest that is not the absence of something, not the rest of exhaustion, which is the body demanding what it has been denied, insisting with the blunt authority of biology that the debt of wakefulness be repaid. Not the rest of relief, which is the release of tension after the thing that was feared has passed, or the thing that was hoped for has arrived. Not even the rest of completion, which is the particular satisfaction of having finished something real, of having moved something from the category of unfinished to the category of done. Those rests are real and they are good, and the body knows each of them by their particular quality, by the specific texture of the settling that each produces. But there is another kind, a deeper kind, the kind that does not require a reason, the kind that is not a response to anything that came before it, but simply a state, a condition, a way of being in the world that the body and the mind are capable of reaching when the conditions are right, and the permission has been given, and the surface has been left far enough behind that its demands can no longer reach down to where you are. You are at that depth now. The continent is around you. not metaphorically, not as a thought about the continent or an image of the continent, or a concept of the continent held in the part of the mind that holds concepts. Around you, in the way that the dark is around you, which is completely and in all directions at once, the way that presence at this depth works, not coming from any particular direction, not concentrated in any particular place. Simply present the way the deep is always present, the way old things are always present, the way things that have been here for 85 million years are present in a manner that has nothing to do with announcing themselves and everything to do with simply continuing to be. Zealandia has been resting for 85 million years, not resting in the way that a tired body rests, not resting in the way that you are resting now, not resting in any way that involves the experience of rest, because the continent does not experience anything, does not know it is resting, does not know anything at all in the way that knowing is something that requires a nervous system and a history and the capacity for awareness that only certain arrangements of matter have ever managed to achieve. The continent rests the way that geological features rest, which is to say that it simply continues being what it is without requiring any effort to do so, without the maintenance cost of wakefulness, without the continuous expenditure of energy that every conscious thing pays simply to remain conscious, to keep the lights on, to sustain the narrative of a self moving through time. The continent pays no such cost. It is here without trying to be here. It is present without effort. It persists without the kind of persistence that requires will or intention, or the continuous renewal of a choice to continue. It simply is, in the way that only very old and very large and very indifferent things can simply be, with the absolute economy of existence that does not require anything beyond the physical laws that govern the behavior of rock. This is what you are approaching now. Not the state of a continent, which is not a state available to anything with a nervous system and a heartbeat and the long, complicated history of being a person in the world, but something in the neighborhood of it, something in the same direction. The direction of less effort, less maintenance, less of the continuous low-level work of being a self that never quite stops during the waking hours, the monitoring and the managing and the presenting and the adjusting, all the invisible labor of consciousness that only becomes visible when it finally, gratefully, puts itself down. Sleep is the putting down. Sleep is the nightly practice of becoming, for a few hours, something less expensive to sustain, something that does not require the lights to be on, something that can let the deep processes run without supervision, that can release the narrative self from its shift and let it rest while the parts of the brain that do not need consciousness to function do the work that consciousness interrupts. The consolidation and the integration and the quiet cellular repair that the body has been saving up for this dark. You have been saving up for this dark, all day, through everything the day contained, through everything that was asked of you and everything you asked of yourself and everything that happened without being asked by anyone. The body has been accumulating the deficit of wakefulness, building the case for rest, preparing the conditions for exactly this. For the moment when the surface is far enough above and the depth is deep enough below, and the permission is full enough that the letting go can be complete. The letting go is not a doing. This is the thing that makes it difficult to describe and easy to fail at when it is pursued directly. You cannot let go by trying harder to let go. The trying is itself a form of holding. The effort of release is itself a resistance to release. The letting go happens only when the trying stops, only when the part of you that is always doing something finally runs out of things to do and falls quiet, and the silence that was always there beneath the doing becomes audible. The continent beneath you is that silence. It has always been that silence. It was there beneath the ocean before any organism on the surface of the planet had a nervous system complex enough to experience anything as silence or noise. It will be there long after the last nervous system that will ever exist has finished its last experience and gone quiet forever. It is the silence beneath the silence, the stillness beneath the stillness, the ground of a rest so complete and so old and so indifferent to anything that is not itself that it makes the rest available to everything that descends far enough to reach it. You have descended far enough. The breathing is slower now. You may have stopped noticing it, which is exactly as it should be, which is the sign that the body has reclaimed the breath from the attention, that the automatic has taken back what the deliberate had been overseeing, that one more thing has been returned to the domain of the body's own wisdom, which is older than any thought you have ever had and more reliable and less in need of your supervision than the part of you that is always supervising things has been willing to admit. Let the body have the breath. Let the body have all of it, the heartbeat and the temperature regulation, and the slow movement of lymph through the tissues, and the consolidation of memory happening in the hippocampus, and the repair of the day's small cellular damages happening in every tissue simultaneously. All the extraordinary labor of a sleeping body that looks from the outside like nothing, and is from the inside the most productive hours of any day. Let the body do what it does in the dark, which is everything, which is more than the waking mind can do or supervise or understand. You are on the continent now in the way that you can only be on something in the imagination, which is completely, without distance, without the separation that physical bodies impose between themselves and the surfaces they rest on. You are in the rock and the sediment and the cold, dark water and the 85 million years of accumulated geological history, not as a thought about these things, but as a presence among them, as the aware point in a landscape that has no other aware points, as the thing that the universe produced from the continent's own material, sent back to know the continent from the inside. You are made of this, not metaphorically. The calcium in the bones that are resting now against the surface beneath you was in the ocean above Zealandia before it was in you, cycling through the shells of organisms that lived above the drowned continent and died and sank and dissolved, and were returned to the water, and eventually, through the long and improbable chain of geological and biological processes that connects the chemistry of the ancient ocean to the chemistry of a living body, became part of the specific arrangement of matter that is you. The water in the cells of your body was in the ocean above Zealandia. The carbon in every molecule that makes you what you are was in the atmosphere above the ocean above the continent, cycling through the bodies of organisms that have been dead for millions of years, returning again and again to the air, and the water and the rock and the bodies of new organisms, the same atoms in different configurations, the same matter in different forms, playing out the possibilities of carbon chemistry across geological time. You are the continent knowing itself, in the only way that anything ever knows anything, from the inside, from within the experience of being a particular arrangement of matter in a particular moment, looking outward at the territory of which it is a part, and finding it extraordinary not because the looking requires extraordinary instruments or extraordinary intelligence, but simply because looking at the world and finding it extraordinary is what consciousness does when it is paying attention. Pay attention for one more moment before the attention itself becomes unnecessary, before the sleep that has been approaching all this time arrives in the way that sleep always arrives, not at a particular moment that can be named, but in the gradual dissolution of the boundary between paying attention and not, between the awareness of the world and the deep processing that happens when awareness steps aside. The continent is here. It has always been here. It was here before any human being knew it was here, and it will be here long after the knowing has passed, and the namers of it have joined the sediment, and the count of the continents has been forgotten, and the ocean has continued its patient business of moving and deepening and covering and uncovering the rock according to the laws that have governed it since before there was water on this planet. The continent does not need to be known to be real. You do not need to understand it to rest on it. You do not need to hold any of this, the geology or the biology or the history of the discovery, or the 85 million years of patient subsidence. You do not need to hold any of it in the part of the mind that holds things, because the part of the mind that holds things is going to sleep, is already most of the way there, is already releasing its grip on the things it has been holding and letting them settle to the bottom of the depth that surrounds you, where they will wait with the patience of geological features for morning. Morning will come. It always comes on this planet with the patient reliability of a rotation that has been happening for 4.5 billion years, and that will continue for several billion more, carrying the surface from dark to light and back again, with the consistency of something that has been doing it long enough to do it without thinking. The morning will come and the surface will return, and the world that was there when you left it will be there when you return, mostly the same, adjusted only by whatever the dark has done to it, and to you while you were not watching. The dark does good work. This is one of the things that the science of sleep has confirmed in the language of neuroscience, in the measurements of brain activity during the stages of sleep, in the studies of what is consolidated and what is cleared and what is repaired and what is integrated during the hours of the dark. The dark does work that the light cannot do. The night does work that the day cannot do. The depth does work that the surface cannot do, and the work is necessary. The body and the brain and the self that inhabits both of them require the dark the way the continent requires the ocean, as the medium in which the work that cannot happen in the air gets done, the slow and essential processing that takes place below the surface and produces, by morning, something that was not there the night before. You will be different in the morning, not dramatically, not in the way that dramatic changes announce themselves. Different in the way that sleep always makes you different, which is subtly and below the level of conscious awareness, in the consolidation of something that was experienced but not yet understood, in the integration of something that was felt but not yet processed, in the quiet repair of something that was taxed by the day and needs the night to restore itself. The morning version of you will have been worked on by the dark, will carry the benefit of hours of processing that the waking mind cannot perform and cannot supervise and can only receive in the morning, as a felt difference that may not have a name. Zealandia will be there too in the morning, beneath the ocean, unchanged by your knowledge of it, unchanged by this night, unchanged by the attention you have paid to it in the dark hours while your body was doing its sleeping work, and the continent was doing its geological work, which is to say, continuing to be what it is. It will be there tomorrow, and for the several billion years after tomorrow, that this planet will continue to have oceans and rock, and the geological processes that move them around each other in the slow and patient dance of plate tectonics. The continent is very patient. It has time for you to sleep. It has time for everything. It is the patience itself, made geological, made oceanic, made real in the 4.9 million square kilometers of drowned continental crust that the instruments finally found, and the scientists finally named, and the world briefly attended to before moving on to the next thing. The way the world always moves on, leaving the continent to its patience, to its silence, to its 85 million years of being present without being known, and its brief recent interval of being known without being changed by the knowing. You know about it now. You have descended into it in the way that imagination descends, which is completely and without the limitations of a body that cannot survive at depth, and you have found it to be what the scientists said it was: real and vast and old and present and indifferent to its own extraordinary nature. Simply here, simply the eighth continent, simply the thing the map was missing that was there the whole time. Take that with you into sleep. Not as a thought to be held, not as a fact to be remembered, but as a quality, a texture, a felt sense of the world being larger and older and more patient than anything the surface suggests. The quality of knowing that beneath every surface there is more, that the map is always smaller than the territory, that the count is always one higher than the current count, that the world keeps offering what it has been holding quietly beneath the water for longer than the question has been asked. Beneath you now is the continent. Beneath the continent is the mantle. Beneath the mantle is the outer core, liquid iron churning in convection currents that generate the magnetic field that protects the surface from the solar wind, that makes life on the surface possible, that has been doing so since before the first living thing drew the first breath of the ancient atmosphere. Beneath the outer core is the inner core, solid iron at temperatures comparable to the surface of the sun, compressed by the weight of everything above it into a density that nothing on the surface can approach. You are resting on the surface of something that goes all the way down to iron at the temperature of a star. This is your planet. This is the ground beneath the ground beneath the ground beneath the ground. This is what you have always been resting on, every night of your life, every night of every life that has ever been lived on this surface, every night going back to the first organism that ever rested, which rested on the same ground, above the same iron, beneath the same dark. The dark has been here longer than the light. The rest has been here longer than the waking. The depth has been here longer than the surface. And all of it, the dark and the rest and the depth, and the continent beneath the ocean and the mantle, beneath the continent and the iron core beneath the mantle, all of it is here with you now. In this room, in this dark, in this specific and unrepeatable moment of a night that will be followed by a morning that will be followed by more of the extraordinary, ordinary business of being alive on a planet that is still, after 4.5 billion years, full of things that the current map has not yet drawn. Sleep now. The continent is patient. The iron core is patient. The morning is patient, turning slowly toward you from the other side of the planet with the unhurried reliability of something that has been doing this for longer than patient is a word. Everything is patient except the part of you that is still awake, and that part is almost gone now, almost dissolved into the depth that surrounds it, almost released from the effort of being awake into the effortlessness of being asleep, which is the closest a nervous system ever comes to the kind of existence that rocks and oceans and drowned continents have. The existence of simply being here without trying to be here, without the cost of consciousness, without the labor of the self. Let the labor go. The continent will hold you. It has been holding things for 85 million years. It is very good at it. It requires nothing from what it holds. It asks only that the thing resting on it stop trying to hold itself up, stop expending the energy of wakefulness on the task of remaining awake, stop maintaining the surface tension of a self that the deep does not require. Release the surface tension. Become the depth. This is what the continent knows that nothing with a nervous system has ever learned to know without practicing. This is what the rock has always known, and what the ocean has always known, and what the dark above the ocean has always known. That the most complete form of presence is the presence that does not know it is present. That the deepest form of rest is the rest that does not know it is resting. That the most real form of being is the being that has nothing to prove and nowhere to be and nothing to maintain and simply is, at the bottom of everything, as old gets, as patient gets, as present as the dark. You are almost there. One more breath, one more slow exhale that takes you slightly deeper than the inhale that preceded it. One more small release of the surface and the light and the noise of the waking world. This is learn when you sleep. And tonight you have learned what the ocean learned 85 million years ago, when a continent finally let go of the surface and allowed itself to descend into the deep. That the going under is not the end. That the dark is not empty. That what rests beneath the surface has not stopped being what it is. That the eighth continent has always been there, patient and real and vast, waiting to be found. And that you, resting now, sinking now, finally and completely surrendering to the gravity of sleep, are doing exactly what the continent did. What all deep things do. You are becoming the rest. You are becoming the dark. You are here. You are held. You are real and old and extraordinary and finally at last asleep.